Welcome back, students. This is chapter 2 that we're kicking off here. What I'm going to do is put the notes up on video. There are a lot of terms for this chapter. So if you look in your red packet, starting, I believe, at page 13, you'll see this. What I'm going to focus on mostly is the naming conventions that we're going to use. The term and the definition's already there. I might add a couple things as we speak about these terms, but the majority of what I'm going to focus on is naming conventions. So here goes. Starting with a point, it's simply identifying a location in space. So off the graph right now is what we're looking at. When we get to the graph with coordinates, that'll be a slight difference, but it's noting a location in space. We've got point A, point B. You're going to put a capital letter right near the location. Now, it says there's no length or width. That means if you can see it, it's too big. Okay, so, we have to draw it so that we can see it, but understand that it's really infinitely small. Okay, now when we name points, you have to use a capital letter. Lowercase letter is technically reserved for something else. We'll have a side of a triangle as a lowercase letter. So what you've got to understand is there's an expectation of how we write things, and we got to be consistent with that. So you can use the word point in front of the letter, but you don't have to. If I see a single capital letter with nothing around it, I can assume the shape they're identifying is a point. Now, that's the only one that won't have a word around it, so we're all in agreement there. All right, a line is next. It's a collection of all points along a straight path. Now, what's going to happen is we need at least 2 points to create a line. So then that's going to create the straight path. Once we have our straight path, you can keep going in both directions for a line. When it says one-dimensional, it simply means that it has no width but an infinite length, and that'll come up in a minute. So when we name a line, we can use 2 points on the line and with the line symbol. Okay, down here, what's going on? I'm naming this same line a number of different ways. That is going to be a question that we fill in on the next assignment. So CE is one name. I'm using 2 letters, 2 points with a line symbol above it. Now CD is the same line, believe it or not. The reason is because the straight path is created by C to D. And since it's a line, it still includes all the points past D, which one of them picks up E. All right, EC, you can switch the order of the letters. CE or EC doesn't make any difference. Okay, there's no endpoint. It keeps going forever in both directions. Now, this is strange. CDE, notice you do have to make sure that it's in order. So I could not say CE then D. That would not be okay. I'm going to say order doesn't matter in a minute, but it as long as you can go CDE or EDC. That's what I mean by order doesn't matter. If you skip C to E and then come back to D, that's not going to be correct. All right, so we'll let that play. Order doesn't matter as long as you don't put the one in the middle outside. Okay, this is another strange way to name a line. Sometimes they'll have a lowercase cursive letter near it. We can identify a line with the word, if that's the case, line M. So we don't use the symbol above a lowercase level, though. So let's not use that line symbol above a lowercase letter M. It's just not how it works. If we're not going to use 2 capital letters, 2 points on the line, if you're going to use this convention, make sure you use the word line in front of it. Okay, some small rules, but what will happen is you'll just have to get used to them. Okay, I'll circle them, highlight them, whatever, mark them as appropriate. So try to learn these conventions. Cursive lowercase, but you have to have the word line in front of it. All right, line's going to be one that's going to take us a little while. There's a lot going on with line. They contain an infinite number of points. That's true. And infinite length, no width, or 0 for the width. All right, down to plane, I forgot to write something down here. So I'll just say it. Okay, I should have said plane G. I don't know why that didn't show up right here. Uh, the word plane and then capital G. So when there's no point around the capital letter, they're trying to say, hey, that's the name of this flat surface. Okay. There's a second way. They might put in 3 points that are not on the same line. So I'm doing that right now, ABC. So we can use, again, you have to use the word plane and then 3 letters. Okay. Now up here, if we just called it G, you're going to be looking for a point. You're going to be thinking it's a point G. You have to say plane G if you're trying to refer to a plane. Okay. There's no symbol for plane. So we need the word plane to identify it. That's really it for the flat surface. We're not going to talk too much about that. It doesn't come up that much in this course. Okay, collinear points. So what we're going to do here is, okay, this is a little strange. A lot of people would think 3 letters is an angle. Now it could be, but if you have 3 letters, 3 points to identify a line, if let's say the Regents ever gives you a question like that, it's really just telling you A, B, and C are all on the same straight path. They're saying one line, one straight path can capture or pass through all 3 points. That's all it's really saying. Or it's indirectly saying A, B, and C are collinear. Okay? So that's the only purpose of writing that way. All right. A, B, and D are not collinear because there's no single straight path that will capture all 3. Okay, so that's basically it. Okay, here's a trick question. A and D, if you look, are not currently connected by a line, but they still are collinear. So this is that interesting fact. 2 points are always collinear. What they're doing on that is, even though it's not drawn, there is a straight path that would connect those. It does exist, so they're collinear. Okay, so 2 points are always collinear. So even though the line's not drawn right now, it does exist. Okay. Let's see, anything else? Yep, there it is. Okay. So make sure you watch out for that trick. That trick's going to come up on a quiz or homework, possibly. Okay, this is one of the ones that I think students can have a tough time with is coplanar. The problem with coplanar is when we're talking about different planes, it's very difficult to draw because we're limited to a 2D piece of paper when we draw. But coplanar is kind of implying multiple planes that's 3D. Okay, so what I try to do is have students think of a prism, right, a rectangular prism like this, and try to think of the different flat surfaces as planes. Now, planes do continue in all directions forever, so it's not quite perfect, but at least it's something to kind of give you a sense to think around. So A, B, and C are all in the top plane, we'd call it, if that top were to keep going forever in all directions. Then what we have is D and E would kind of be in the bottom plane, so underneath it. So you've got a top plane and then a different one that has, D and E. So we'll keep going for a minute. Okay, there is a single flat surface that contains all 3 of these. The top, yeah, it's talking about that. B, C, and D. Yep, that's the back, right? The back of the prism is a flat surface that would contain those. Okay, so this is the trick question. A, B, D, and E. So think about A, B, D, and E. This one's tricky. The flat surface that would contain all 4 of these points is not drawn yet. Okay. But there is a flat surface. If you think about it, you could find, like, think about maybe a piece of plywood or something, a flat surface. you could line up a piece of plywood with A and B and turn it almost like a hinge, right? That would be able to contain D and E along that one flat surface, or a piece of paper could take us, from connected to A and B, and at the same time turn so it catches D and E as well. So even though it's not drawn, there does exist a flat surface that would catch all four of these. That makes A, B, D, and E coplanar. It's a little bit tricky. So we might need some more examples of that in class, which we will take a look at when it comes up. Okay, so you can have 4 points that are coplanar. Now I'm going to 4 points that are not, A, B, C, and D. So A, B, and C are on along the top plane. I'll pause that for a second. If you remember my picture from up above, A, B, and C were all on the top plane, and then D was underneath. And there is no single flat surface that would catch all four of those. All right, line segment. Now we're going to go with a line segment, 2 endpoints. That's weird, right? You would think a start and an end. That's not how it works. Basically, endpoint is used to say, all right, it's where both, we stop in both directions, okay? So endpoint is it stops. It gives us a length that's finite. There's a number that we can get to, which we'll show you. Whereas before you go on forever, a line goes on forever. A segment it's going to stop, so it does have a finite length. Okay, connects 2 points. All right, so the endpoints give us the 2 points that create the initial straight path, but there's infinite number of points between them. All right, and every line segment still has an infinite number of points, but a finite length. So I think we're going to talk about that here. 2 endpoints. It's not a start and an end. Okay, it's because we end in both directions. The straight path ends in both directions. Now, what you're seeing is, this is strange. I drew a line. I have arrows on the end. It's implying it goes on forever. But I can identify just A to B. So I can stop. See, I didn't put the arrows on, so it doesn't keep going. So none of these points count. It's only the points from A to B along that straight path in between, and inclusive. The direction, A to B or B to A, doesn't matter. Okay. And when there's no arrows, basically it's telling us it stops. All right, you can have 3 letters to identify a segment, as long as they're in order. Okay, CE this time is not the same as CD because it's not a line, right? This doesn't go as far. Okay, directed segment. What I want to teach you about that is, think of a vector in science. Okay, now the order does matter. If I tell you it's a directed segment, it's almost like a ray, but it's not. Okay, a ray goes forever in one direction. A directed segment does not go forever. It has a finite length as well, but the difference between the directed segment and a segment is simply the direction. You start, in this case, at A, and you stop at B. So you have to go in that direction. There is a start and an end. Okay, for a segment, there's just 2 ends. Okay, doesn't matter what the start is. So for a vector in science, okay, they're going to call the length of a vector, they're going to call it something different. So if you ever hear the word magnitude in science, that's basically the length, okay, the distance between A and B. We'll get to some examples of that, okay, but the directed segment, it almost looks like it's a ray, which would be infinite length. It is not. Okay, it does stop. It's just got a direction. Okay, AB, what I'm showing is, if you, AB, the directed segment, AB, that's the symbol. Okay, looks like a ray, but it's only got the top part. Means you start at A and move towards B. Okay. Now, what I'm showing is the congruent symbol, and it's not congruent because these have different directions. If you start at B and move to A, that's a different direction. Okay. Now, you cannot point the arrow to the left. That's incorrect. The arrow, just like we read, you have to read left to right. Now, that's going to be the case in rays, directed segment symbols. Please make sure that you don't switch it around. That's going to be, you're going to see me mark that wrong. Okay. This is not allowed. All right. And that's all for this one. Okay. The notes, I'll pick up the rest of the notes in another video.